where you manage the water is crucial to getting your basement as dry as possible. What happens with systems that sit on top of your footing is the water has to fill up the entire area underneath your floor. Now, the ability for this to catch water is very limited. What occurs is water is seeping. You can see it's seeping right through here. Water comes over the top of the footing and then would ideally run down the footing, and you would have your drainage down within the depth of the footing, and that would keep the entire floor area completely dry, and the area between the bottom of the floor and the bottom of the footing free of water. That's the way to get the basement as dry as possible. With this type of system, water doesn't just come in and go right into this tract, which is what people are led to believe. This has a lip on it. If you notice the lip that's right here, it's about 1/8 of an inch or so. Water, when it comes up against that, doesn't go right in. It bypasses, and that water flows across the footing into the area underneath the floor and floods that whole area, the aggregate area, and fills up with water so that the whole floor is sitting in water. Right now, this system is sitting on top of the footing, but the water is filled up all the way around the entire floor, and the whole floor is sitting in water. Concrete is porous, so it's going to absorb a lot of that water, and the floor is going to always have a dampness to it. That restricts what type of flooring you can use if you're ever going to finish your basement. So when this type of scenario occurs, water will flow through this gutter type system and go to the sump basket and then be pumped up out away from the house. But you already have, if you look here, you can see the water's being managed, about 1 inch away from critical, meaning on top of your floor. So here we can determine just how thick your floor is. That piece would be up against the wall, so you can see you have about this much floor. Now, once you remove the floor off the footing and you put your drainage in, this drainage now is sitting where there was solid floor, so it limits how much cement you actually can put back on top of here. And this was a system that was in another basement that was taken out for several different reasons. But you can see the thickness of the floor that was replaced was right up to about here, and that pretty much coincides with this foundation here. Well, this foundation has an awful lot of water, and I can show you with stark contrast the different ways of going about waterproofing it. If you've noticed, if you take a look down here, you can see there's part of the floor has been left intact. That's what we call an engineering tab. So if you look here, we're going to be doing those engineering tabs periodically around the foundation, so we keep that support of the footing holding up the floor, and we still keep the floor holding the walls out. If you look, here's another spacer here, and right around the corner here, we have a third one. The other thing too is, if you're managing water within the depth of the floor, water's got to come up against the bottom of the floor and then travel sideways across the bottom of the floor to get over to this gutter type system, this top of the footing type of water drainage. That constant flow of water underneath your floor can change the type of support that the soil is giving it and can reduce that. So this type of system can actually cause undermining of the main body of your floor just in the normal process of managing the water. With the engineering tab, it doesn't rely on the support of the soil underneath the floor. But if you were to remove this part of the floor, in other words, take the floor off the footing around the entire foundation, your floor would only be supported by whatever soil was underneath it. And if you have a system that sits on top of your footing, water's got to come up, flow towards that drainage, and it's going to be flowing through the soil that's underneath the floor. It's going to weaken the support for the floor, and that floor, you have to remember, is no longer on that footing being held up. Now, as far as the overall strength of your floor, the floor that was removed was about 4 inches thick. When you put your drainage on top of the footing, that goes in place of where your floor was. So it's reducing the amount of floor that you can put back to about 1 inch, give or take 1/4 of an inch. So you're going to have 1 inch, 1.25 inches of floor on top of your drainage over to the main body of the floor. and that's going to do nothing to give support to the main body of the floor. So you've drastically reduced the overall strength and integrity of your foundation. If you're taking the floor off the footing in a traditional three-piece foundation, it's virtually impossible to get all of that structural integrity back. Now we've installed our pipe. We've established a pitch so that water is going to be flowing one direction through our corrugated perforated ADS pipe, and that pipe's packed in stone. So now, here's what we have. Water will continue to seep underneath the wall and across the footing, but it will go over, and now it has drainage in order to take that water away to our sump station and then pump the water out away from the house in a way that it will never be recycled again. But all of this drainage, instead of that water filling up to this level here, this water is now being managed within the depth of the footing. This is what we call the magic zone. By setting up all of this drainage down here within the depth of the footing between the top and the bottom of the footing, the whole entire floor will never come in contact with that standing water. The concrete floor will dry out. You're going to have a dry floor. You could use tile, you could use carpet, you could use hardwoods, all things that with the other type of system, you'd be restricted from using that type of flooring in the event that you wanted to finish. So, once again, back to that magic zone, if you're managing that water within the depth of the footing, you've solved your problem. If you manage it within the depth of the floor, you're actually creating another problem. And the only way to do that is to take the floor entirely off the footing all the way around the foundation, and that severely weakens the overall strength and integrity of your three-piece foundation. Now, if you have an issue with your basement, feel free to call us at American Dry Basement Systems or to look us up on the web at americandry.com. Thanks for watching.